Hey everyone, it's Alice here from Top Mark Science, and today we're going to be looking at the pH scale. Throughout this video, we'll be exploring what the pH scale looks like, what each part of the scale shows, and using the pH scale to test various substances. Let's get started. In our last video, you can probably guess that we looked at indicators. Chemical indicators are substances that change colour when added to another. The colour they change will depend on the type of substance, and this substance might be an acid or an alkali. We can use red cabbage from our fridge at home and add it to hot water to make red cabbage indicator. And when added to an unknown substance, it can change colour. We saw that if red cabbage indicator is added to acid, it turns red, and alkali, it turns yellow. And each colour has its own number. Litmus paper comes in red and blue strips that when added to an unknown substance, red staying red means acid and turning blue shows alkali, or blue staying blue means alkali, or blue turning red means acid. Now the key issue with using litmus paper is that we may get a general grasp of either extreme. But what about everything in between? This is where universal indicator comes in. A widely used indicator in science labs that often comes as a green liquid in a small bottle, extracted using a pipette. It produces changing colours of smooth transitions like that of a rainbow. And like red cabbage indicator, each colour is associated with a number on a scale. This is called the pH scale. The pH scale is a measure of how acidic or alkaline a solution is, with those most acidic substances down at the low pH numbers and alkali at the high pH numbers. Pause the video here and work through tasks 1 to 3 on the screen. If you finish, try the challenge. Let's see how we got on with each section. And like my other videos, annotate your work as we go, so you have something that you can revise from later. Firstly, we should have the rectangles, or something equivalent, drawn on your piece of paper. Then these can be numbered from 1 to 14, which we gradually start to colour in using smooth colour transitions of pH 1, red, to 2, orange, 3, lighter orange, 4, turning more yellow, 5, a yellowish green, 6, a light green, 7, green, 8, darker green, 9, blue, 10, darker blue, 11, darker blue, 12, bluish purple, 13, purple, and 14, dark purple. The remaining colours on the screen were already filled in at the beginning to help you start. So let's remove those and have a look at this challenge. You now have the pH scale for reference, but we also need to know what each part means. As we mentioned earlier, the lower pHs relate to the acids. The lowest pH means the stronger acid. And as the pH gets higher, the acid weakens until we reach the middle, which is neutral. And on the opposite side, the highest alkali is therefore the strongest alkali, and anything less than those are weak alkalis. What we'll look at now is a little virtual experiment. Pause the video here and try tasks 1 and 2 for a little prep. If you finish, try the challenge. Okay, so first of all, we should have the results table copied onto a sheet of paper with a prediction of what you think each substance might be. In terms of a method, it could look something like this. Use a pipette to transfer 2 millilitres of a substance into a spotting tile. Use a different pipette to add 2 drops of universal indicator into the same well. Using a different pipette is important to avoid contamination. Note down the colour that it changes to, and select a different substance to test and a new pipette. You can then repeat steps 1 to 3 for the rest. Now you may not have the exact numbers, but you want a method to be in a logical order. mentioning key pieces of equipment like pipettes and spotting tiles, and mention the steps involving taking measurements. Don't worry if you didn't get all the points. There are many ways that you can write it, and it takes practice. Okay, so let's get started. My spotting tile is ready. Let's extract 2 millilitres of stomach acid, aka hydrochloric acid, and transfer it over into my first well. Now I can use a different pipette to extract some universal indicator. Add 2 drops into the same well as the stomach acid and observe any colour changes, which I can see it's turned red. And I can note this down in my results table as I go. Now I can move on to the next substance on my results table, water. Use a new pipette to avoid contamination and add 2 millilitres into the next well on my spotting tile. Take some more universal indicator, add 2 drops and see the result of colour and note this down in my results table. I can repeat these steps for baking soda, which turns blue, urine turns a yellowish green, soapy water turns purple, drain cleaner turns dark purple, black coffee a yellowish orange, and finally ammonia, a strong blue. Before moving on, take some time to ensure you have these results in your table because these will help with some analysis. Pause the video here and use your results to compare them to the pH scale. Use the pH scale to help you complete your results table. The results in the spotting tiles are labelled A to H and correspond to the results A to H in the results table. If you finish, try the challenge. Let's go through the answers. Annotate and complete as we go if you have left any gaps, or give yourselves a tick if you got some parts correct. So we can see that A, stomach acid, is a strong red. This matches quite nicely with pH 1, a strong acid. B, water, is this green colour, pH 7, neutral. C, baking soda, is blue, pH 9, a weak alkali. D, urine, turns this yellowish green somewhere between pH 5 and 6, so we can note down 5.5, a weak acid. E, soapy water, is purple and matches to pH 12, a weak to strong alkali. F is drain cleaner, a dark purple which matches up with pH 14, a strong alkali. G, black coffee, is a yellow-orange, somewhere between pH 5 and 4, a weak acid. And lastly, H, ammonia, a darker blue of pH 11, so still considered a weak alkali. Well done if you managed to get some of these, but it was great practice of using the pH scale to determine types of substances, in addition to experimental practice. If you finished, you may have tried the challenge, which was describe what type of substance rain is at pH 5 and what might cause this. Rain at pH 5 is considered a weak acid. This is known as acid rain, which can be caused by air pollutants and compounds that react with water in the atmosphere. It can cause damage to buildings and be harmful to wildlife. If you have time, here are some additional practice questions using your knowledge on the pH scale. Pause the video here to have a go and resume the video when you're ready to go through the answers. Okay, let's have a look at these then. A bee sting of pH 6 is a weak acid. Human skin of pH 5.5 is a weak acid. Toothpaste of pH 9 is a weak alkali. Substance X is green, which means it's neutral, pH 7. Substance Y turns pale yellow, so it could be in the range of pH 6 to 4. And substance Z is slippery and corrosive. This means to test it, we should use universal indicator, and these properties suggest it's a strong alkali. Before we finish with our end of video quiz then, just a quick fire set of high or low questions on different substances. A word will appear on the screen. Use a thumbs up for a high pH, thumbs down for a low pH, or middle for neutral. Battery acid, low. Bleach, high. Water, neutral. Seawater, somewhere between neutral and high. It's considered somewhere between neutral and alkali. And last one, hydrochloric acid, is low. Okay, to finish up with our quiz then. Question 1. What do we call the measure of how acid or alkali a substance is? The pH scale. Nice one to start. Well done. Question 2. What indicator gives the rainbow spectrum? Universal. Excellent. Question 3. What numbers generally do the pH scale range from and up to? 1 to 14. Question 4. A very low pH means something is very acidic. Nice work. And question 5. Something that tests pH 9 can be described as a weak alkali. Well done, everyone. Pause the video here to see how your knowledge has progressed since the start of the video. It will also help you find areas for revision. Thank you so much for watching this video, guys. If you enjoyed it and would like to see more from Top Mark Science, you can like this video, subscribe to my channel, and you can now find us on Facebook for additional resources, teaching and study tips, and general updates. Thanks for coming, and I'll see you next time.